In example 5, you're given a picture of the graph of a power function that basically has a negative exponent. So basically this is a rational function because that would put the variable in the denominator. And you're asked to determine the answers to these questions here. So you know that now it's saying that n itself is greater than 0, so negative n is going to make this a negative value. So that's why it's defined that way. It's a little confusing for some, but that's what's been going on here. It's basically ensuring that this negative n is indeed going to be a negative value because you're only allowing the n itself to be positive. So you're asked, is n even or odd? So is this exponent that's negative, is it going to be an even number or an odd number? If it was an even number, you would be seeing a graph that would look more like this. Either the two ends would be like this and like this. They'd either be both going in the up direction or both going in the down direction. So this is obviously going to have an odd exponent here. Now, is k greater than or less than 0? Is the k value positive or negative? If it was negative, you would see it start off higher on the left and be lower on the right. This one's starting lower on the left and higher on the right. So it's negative for values that are below the 0 but that are positive, and it's going to be positive for those that are over that. So it's definitely greater than. These two questions are centered around something you're going to see about whether it's an even or an odd function, and we're going to get more into that and other things as we move along with this. But does f of negative x equal f of x? That means if you change the sign of an x coordinate, do you get the same y coordinate as the original? So like say looking here, it looks like you have a point at 1, 2. Well, for this to be yes, that means that you would have a negative 1, 2 as well, and you notice that's not a point here. So the answer to this question is no. Now this one here says, okay, does f negative x equal negative f of x? That means that if you change the sign of an x coordinate, will it change the sign of the y coordinate? So here, this has 1, 2. This one at negative 1, it's at negative 2. So that did change. So changing the sign of the x coordinate changed the sign of the y coordinate as well. So this is yes. Now, when you deal with these rational functions or these power functions that have negative exponents, you start seeing two other features of the graph. First, you have a vertical asymptote, which is a vertical line that the graph will approach but never ever cross. You also will tend to have a horizontal asymptote, or sometimes you might have an oblique asymptote where it's more of a slanted line. Those define what's known as the end behaviors of these types of graphs. Horizontal asymptotes, the graph can pass through them at times. However, if it's a really basic power function, it probably won't. And along with that, it's only defining an end behavior, so you're only going to see that as x goes to infinity or negative infinity. You can see here, as you keep getting bigger and bigger and bigger for x values, this one is approaching a horizontal line at y equals 0. And the same thing for this as I go to negative infinity. So as x goes to infinity, f of x is going to approach 0, and the same thing as it approaches negative infinity. That is defining basically what the horizontal asymptote is telling you. And so that's how you kind of differentiate the various things with this and tell about certain things about it just by looking at the graph. For the next problem, they're having you do some graph transformations, which they're going to get a little bit more complicated with these as you move to other parts of the lesson in chapter 7 and even chapter 8. So you're beginning with the function f of x equals 1 over x to the fourth. You're being told that g of x is created by vertically stretching that by a factor of 3. H of x is going to be created by vertically compressing that function by a factor of 1/5. And j of x is going be created by vertically stretching it and reflecting it across the x-axis. All of these are vertical transformations. As it says vertically, 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 reflecting across the x-axis, that's the horizontal axis. That means you're going to be changing y coordinates for each and every one of these. So these are vertical transformations, which vertical transformations are usually easier to work with than the horizontal ones. You're going to see horizontal ones as we progress, but they're a little trickier to work with, and they have some other pitfalls you have to be aware of. Vertical transformations aren't that bad, because to vertically stretch f of x by a factor of 3 means you would be multiplying all of the y coordinates of this guy by 3, which means you're taking this function here and you're multiplying it by 3. So this is going to be 3 times f of x. Well, 3 times f of x would be 3 times this 1 over x to the 4th, which would give you 3 over x to the 4th. So that would be the equation for the function of g of x. Works the same way with compressing. If I'm going to shrink each of the y values by a factor of 1/5, that means I'm multiplying all the y coordinates by 1/5. And so this function h of x is going to be the result of me taking 1/5 times the function value f of x. Well, if I do 1/5 times this, I'm going to end up with 1 over 5x to the 4th. And so that's what the equation of that function would be. The vertical stretch is not going to be a big issue here because we've already saw what a vertical stretch did. I mean, that means you're going to multiply by a 2. But the fact you're reflecting it across the x-axis, which means any positive y coordinates are going to become negative and vice versa. So you're not multiplying by 2 only, it's going to be a negative 2. So I'll be multiplying f of x by a negative 2. And of course, if I do negative 2 times 1 over x to the 4th, I end up with negative 2 over x to the 4th power. And so that is the end of this problem, and that is the end of this video. If you have any additional questions, please make sure to bring them up during class.